Our next lesson is combining what we did with greatest common factor, which was pulling out common terms from out front, with then factoring either a trinomial or a difference of squares that we can turn into a trinomial. So let's take a look at example 1. Okay, up here I've listed the steps before we get started. So the first thing we're going to do, and you need to write this into your notes, is to look to take out a number or letter GCF from all terms. Look for x squared x and number form of what's left, or x squared minus a number, which we will then factor into the parentheses. Then we're going to write our final answer in this greatest common factor out front, and then the two parentheses that we factored second. So this is a multi-step problem that's going to require you to do 2 lines of work at the very least. If I look at number 1, factor completely, I look really good from the standpoint that I have k squared, k, and a number. However, 4, 12, and 8 have a GCF of 4. So if I notice, this is 4 times 1, this is 4 times 3, this is 4 times 2. So from each of the numbers, my GCF is 4. On the inside, that leaves me with 3 terms. 1k squared plus 3k plus 2. Now my second step is to look for x squared x in a number, k squared k in a number. I have that form. So now I'm going to go back to my factoring rules. K and k. Bring down the plus. Plus times what gives me plus? Positive. 2 and 1 multiply to give me 2, but activate to give me 3. And then I have to bring down my GCF 4 out front. So this was the factoring work I did, and this was me bringing the 4 out front. This is factored completely. Moving down to number 3. Number 3 has 5r squared, 20r, 105. This is very close again to the form, but I need to take out a number out front. 5 times 1, 5 times 4, 5 times 21. 5 is my greatest common factor. It leaves me with 3 numbers on the inside. 5 times 1r squared gives me 5r squared. 5 times negative 4r gives me negative 20r. And 5 times positive 21 gives me negative 105. Error there, that should be a minus sign. Okay, step 1 is GCF. So notice I'm taking these 5s out front and leaving everything else, including the signs and the letters. From here I'm going to factor r and r, bring down the minus. Minus times what gives me a minus? The answer is a plus. 7 times 3 is 21, activates to give me 4. I need opposite signs, so it's subtraction. Bring down the 5. That is my final answer. Number 5, same thing. 2 times 1, 2 times 13, 2 times 36. Take out the 2, that's my GCF. P squared plus 13p plus 36. Now I move on to factoring. P and p is here. Bring down the plus. Plus times what gives me a plus? And this is going to be 9 and 4 with the 2 out front. 9 times 4 multiplies to 36, but 9 plus 4 gives me 13. When the signs are the same, which they are here, that's what tells me I need to add. Next example. 4 times 1, 4 times 4, 4 times 3. 4 is a number that can be taken out of all 3 terms. And then I have b squared b in number form, which is what I'm looking for. Take out a 4, b squared minus 4 plus 3. There's a b here. Notice signs match. I'm writing down what's left over after I take the 4 out of each of them. B and B. minus times what gives me a plus, minus what number multiplies to give me 3, but then adds to give me 4, 3 and 1, and I'm done. Okay. Moving on to number 9. 2 times 1, 2 times 1, 2 times 90. 2 times n squared minus 1n minus 90. 90 is tricky because you need two numbers that multiply to give you 90 but activate to 1. In this case, that's going to be 9 times 10 because when you multiply you get 90, but when you subtract them, you're going to get 1. So I can set up my parentheses, n and n. Notice how I'm automatically bringing down my GCF, but I'm not using that in my calculation. Now I'm worried about factoring what's left over. So I come up here and I say this is a minus. Minus times what gives me a minus, plus 10 is the bigger number, followed by 9. My final answer includes the GCF and my two parenthesis groups. Now, number 11. Number 11 is a little bit trickier. You probably see this initially, and this is how I know if you're watching the video or not, as 10x and 10x and 64 is 8 and 8, plus minus. But that didn't take into account GCF. So if it says factor completely, yes, it is difference of squares. These are both perfect squares. But I can actually take out 4 times 25, and I can take out 4 times 16. Gives me 64. So there's my GCF of 4. That leaves me with 25x squared minus 16. Both of these are perfect squares. Bring my GCF out. 5x and 5x. Notice I don't have x and x anymore. My signs are plus minus, and the two numbers are 4 and 4 that multiply to give me 16. Last two problems. Take out a 3, k squared minus 1. Remember, this could be k squared plus 0x minus 1. That's going to give me k and k, plus 1 minus 1, and I'm done. K squared minus 1 or x squared minus 1 comes up a lot, so you need to recognize that as difference of squares. Last one is GCF. This is 2 times 16 and 2 times 1. 16x squared minus 1. There's that minus 1 difference of squares again. 4x and 4x plus 1 minus 1. Please message your teacher if you have questions or concerns.